In this family, what is the big number? The big number is 5. What are the small numbers? The small numbers are 2 and 3. Remember, the big number is always at the end of the arrow. Here's a number family that has blanks for the numbers. Is this a blank for a big number or a small number? It's the big number. Is this a blank for a big number or a small number? It's a small number. Is this a big number or a small number? Big number. And is this a big number or a small number? Small number. Now here's a rule about number families. If the big number is missing, you add the small numbers to find the big number. Listen again. If the big number is missing, you add the small numbers to find the big number. Is a small number or a big number missing in this number family? The big number is missing. What do you do to find the missing big number? Yes, you add the small numbers. Is a small number or a big number missing in this number family? A small number is missing, so you don't add. Is a small number or a big number missing in this number family? The big number is missing. What do you do to find the missing big number? Yes, you add the small numbers. Number families also show how to write subtraction facts. If a family has a missing small number, we always subtract to find the missing number. We start with the big number and subtract the small number. What's the big number in this family? We start with the big number 6 and subtract the small number. We go backwards along the arrow. The subtraction problem is 6 minus 5 equals how many? Here's the next family that has a missing small number. Remember, we go backwards along the arrow. We start with the big number and subtract the small number. Say the subtraction problem for this family. 18 minus 9 equals how many? Here's the next family that has a missing small number. Remember, we go backwards along the arrow. Say the subtraction problem for this family. 9 minus 5 equals how many? You've learned to write one addition fact and one subtraction fact for a number family, but most families tell about 2 addition facts and 2 subtraction facts. Say the addition fact that goes forward along the arrow. 1 plus 5 equals 6. The other addition fact also ends up with the big number. 5 plus 1 equals 6. Say the addition fact that starts with 5. Here's a new family. Say the addition fact that starts with 2. 2 plus 3 equals 5. Say the addition fact that starts with 3. 3 plus 2 equals 5. One subtraction fact for this family starts with the big number and goes backward along the arrow. Say that problem. Nine minus 3 equals 6. The other subtraction fact also starts with the big number. 9 minus 6 equals 3. New family. One subtraction fact starts with the big number and subtracts this small number. Say that fact. 5 minus 3 equals 2. Now, say the subtraction fact that starts with the big number and subtracts the other small number. 5 minus 2 equals 3. We've learned to write addition and subtraction problems for number families. What do we do to find the big number when it is missing? We add. What do we do to find a small number when it is missing? We subtract. When a number family has two-digit numbers, we can write a column problem. Is a small number or the big number missing in this family? A small number is missing. Say the subtraction problem for this family. 66 minus 24 equals how many? When we write the problem in a column, we don't need a box.
Here's a column subtraction problem. Remember the rule for working these kinds of problems. First, subtract in the ones column, then subtract in the tens column. If there is a hundreds column, subtract in that column last. Here's a funny problem. First, we subtract in the ones column. What's the answer? 9 minus 8 is 1. Now we subtract in the tens column. We start with 3 in the tens column, but there's nothing to subtract, so we just write 3. Here's a column subtraction problem. Figure out the answer in the ones column. What's the answer? Yes, 1. Now, figure out the answer in the tens column. What's the answer? 3. In the hundreds column, the problem says 3 minus 3. What's the answer? 0. But when the first digit of the answer is 0, we don't write anything. This is the answer to the problem, 31. If this was the problem we were working, then the answer would be 3. For this problem, the answer in the tens column is 0. Remember, if the first digit in the answer is 0, we don't write anything.
This table has words that tell about the numbers in the rows and columns. The columns show the hours people worked on Tuesday, Wednesday, and Thursday. The rows show hours worked each day for Ben, for Tyler, and for Maria. Here's the column that tells about hours worked on Tuesday. How many hours did Ben work on Tuesday? Ben worked 4 hours on Tuesday. Here's a table. The arrows show that the rows of the table work just like number families. The first two numbers are the small numbers. The total is the big number. In the row for this number family, is the missing number a big number or a small number? A small number is missing. Do we add or subtract to find the missing number? Say the subtraction problem. 48 minus 37 equals how many? In the row for this number family, is the missing number a big number or a small number? A big number is missing. Do we add or subtract to find the missing number? Say the addition problem. 15 plus 18 equals how many? In the row for this number family, is the missing number a big number or a small number? A small number is missing. Do we add or subtract to find the missing number? Say the subtraction problem. 35 minus 33 equals how many?
We're going to work some word problems. In these problems, if a person gets more, buys more, or finds more, we add, and we end up with a big number. If a person gets less, sells some, or loses some, we subtract, and we end up with a small number.
Here's another problem. A store had 78 fish. The store sells 55 fish. How many fish does the store end up with? The store sold fish, so we'll subtract. The first sentence says that a store had 78 fish. We write 78. The next sentence says that the store sells 55 fish. We subtract 55. The last sentence says, how many fish does the store end up with? We write an equal bar.
We're going to write the place value addition for these numbers. This number is 26. The place value addition for 26 is 20 plus 6. Next number. Say the place value addition for 41. 40 plus 1. Next number. Say the place value addition for 37. 30 plus 7. Last one. Say the place value addition for 62. 60 plus 2. When we work subtraction problems that use borrowing, we have to rewrite numerals so we have a new place value addition. We're going to rewrite 84 for borrowing. We borrow 110 from the tens column and add that 10 to the value in the ones column. How many tens do we start with? We cross out the 8 and write the number that is 1 less than 8. What number is that? 7. Now we take the 110 we borrowed and write it in front of the 4. The new place value addition is 70 plus 14 equals 84. Say the new place value addition. New number. We borrow 110 from the tens column and add that 10 to the value in the ones column. How many tens do we start with? We cross out the 5 and write the number that is 1 less than 5. What number is that? 4. Now we take the 10 we borrowed and write it small in front of the 7. Say the new place value addition for 57. Yes, 40 plus 17 equals 57. We've learned that when working subtraction problems that use borrowing, we have to rewrite numbers with a new place value addition. To rewrite 52 for borrowing, first we borrow 110 from the tens column. How many tens do we start with? We cross out the 5 and write a number that is 1 less than 5. What number is that? 4. Now we take the 10 we borrowed and write it small in front of the 2. The new place value addition is 40 plus 12 equals 52. We're going to do borrowing. For some problems, we have to rewrite the top number so we can subtract. For other problems, we just subtract. First, we read the problem in the ones column. If the bottom number is bigger than the top number, we have to borrow. Say the problem in the ones column. Can we work 7 minus 6? We can work it, so we don't have to borrow. New problem. Say the problem in the ones column. Can we work 7 minus 7? We can work it, so we don't have to borrow. New problem. Say the problem in the ones column. Can we work 7 minus 8? The big number is on the bottom, so we can't work it. We have to borrow. New problem. Say the problem in the ones column. Can we work 7 minus 9? The big number is on the bottom, so we can't work it. We have to borrow. Here's how we work problems when we have to borrow. First, we rewrite the top number. We write the number that is 1 less above the tens digit. We write the one we borrowed small in front of the ones column. Now the problem in the ones column says 17 minus 9. Not 7 minus 9, 17 minus 9. What's the answer? 8. In the tens column, we have 4 minus 3. What's the answer? 1. New problem. Say the problem in the ones column. Can we work 4 minus 9? The big number is on the bottom, so we can't work it. We have to borrow. We rewrite the top number. We write the number that is 1 less above the tens digit. What number do we write? 3. We write the one we borrowed small in front of the ones column. Say the new problem in the ones column. It's 14 minus 9. What's the answer? 5. Now the tens column. Say the problem. We have 3 minus 1. What's the answer? 2. Here's a subtraction problem with hundreds numbers. Say the problem in the ones column. Can we work 7 minus 9? We can't work 7 minus 9, so we have to borrow. We have to rewrite the last 2 digits of the top number. What are the last 2 digits? We rewrite 47. Now say the problem in the ones column. Can we work 17 minus 9? We can work the ones column. Say the new problem in the tens column. Can we work 3 minus 3? We can work 3 minus 3, so we can work the whole problem now. New problem. Say the problem in the ones column. Can we work 8 minus 9? We can't work it, so we have to borrow. We have to rewrite the last 2 digits of the top number. Say the last 2 digits. We rewrite 68. Now say the problem in the ones column. Can we work 18 minus 9? We can work the ones column. Say the new problem in the tens column. Can we work 5 minus 4? We can work 5 minus 4, so now we can work the whole problem. When we rewrite numbers for borrowing, we end up with a 2-digit value in one of the columns. The line under the 7 means that we want the 7 changed into a 2-digit value. Say the digit we cross out. We cross out the 5 and write a number 1 less than 5. In which column do we write the one we borrowed? Here, in the ones column. Say the new 2-digit value in the ones column. There's 17 in the ones column. We can do the same thing to get a 2-digit value in the tens column. We have to borrow from the hundreds. Say the digit we cross out. We cross out the 2 and write a number 1 smaller than 2. What number? Yes, 1. And we write the 1 in the tens column. Say the new 2-digit value in the tens column. We have 15 in the tens column. When the problem in the ones column begins with the smaller number, we have to rewrite the top number. We do the same thing when the problem in the tens column begins with the smaller number. The problem in the ones column is 4 minus 3. That answer is 1. In the tens column, the problem says 6 minus 7. Can we work that problem? We can't work 6 minus 7, so we cross out a digit in the top number. Which digit? We cross out the 8 and rewrite 86, so we have a 2-digit value in the tens column. Say the new problem in the tens column. In the tens column, we have 16 minus 7. Say the new problem in the hundreds column. It's 7 minus 2. Here's a problem that involves borrowing. Say the problem in the ones column. Can we work 3 minus 2? We can work it, so we don't have to borrow. What's the answer? 1. Say the problem in the tens column. Can we work 5 minus 7? We can't work it, so we have to borrow. We rewrite 2 digits of the top number. What are those 2 digits? We rewrite 25 tens. In the tens column, we have 15 minus 7. That's 8. And in the hundreds column, we have 1 minus 1, so we don't write anything. Here's another problem that involves borrowing. Say the problem in the ones column. Can we work 4 minus 6? We can't work it, so we have to borrow. We rewrite 2 digits of the top number. What are those 2 digits? We rewrite 24. In the ones column, we have 14 minus 6. That's 8. Say the problem in the tens column. Can we work 1 minus 1? We can work it, so we don't have to borrow. And in the hundreds column, we have 6 minus 4. That's 2. Sometimes you have to borrow to work the problem in the ones column, and sometimes you have to borrow to work the problem in the tens column.
Here's a sentence from a word problem. We're going to make a number family for this sentence. The first letter of each name is underlined. Those are the letters we'll use. The sentence says, Matt has more books than Juan. Matt has more, so Matt is the big number, and Juan is a small number. That's how we make the number family with letters. New sentence. Jess has fewer books than Troy. Is Jess the big number or a small number? Jess is a small number. Troy is the big number. What letter do we write for Troy? Here's the T for Troy.
We've made number families for sentences like this one. First, we have to figure out which person has the bigger number. That's the person who has more or goes more. The sentence says Manuel has more cards than Brad. Who has the bigger number? Since Manuel has more, Manuel is the bigger number. What letter do we write for the big number? M. And B for Brad is a small number.
Bianca had 145 stickers. She gave away 17 stickers. How many did she end up with? Bianca is getting less, so we subtract 145 minus 17. The answer is 128. The unit for the answer is stickers. Bianca ended up with 128 stickers. When you work word problems from now on, write the unit name in the answer.
We've made number families for sentences like this one. It says, how much older is Brett than Devin? The sentence lets us know that one of the persons is older. Who is older, Brett or Devin? Brett is older, so Brett is the big number. What letter do we write for the small number? D is the small number. The sentence asks, how much older? What do we write for how much? We write a box for how much, and it is a small number. This is the number family for how much older is Brett than Devin. We've learned to work problems like this. Nothing is underlined in this problem, but the last sentence tells how to make the number family. How much shorter is Jackson than Eric? What letter do we write for the big number? Eric is the big number. Jackson is shorter, so J is a small number. How much is a box? The first sentence says that Jackson is 54 inches, so we replace J with 54. The next sentence says that Eric is 72 inches, so we replace E with 72. Now we can write the subtraction problem, and we get 18. The unit name in the answer is inches. This is a thousands number. How many digits does it have? It has 4 digits. For this number, there's a 7 in the thousands column and a 2 in the ones column. This number is 7002.
This is a big thousands number. We can tell it's thousands because it has 3 zeros. Here's how we say numbers like these. We say the numbers before the comma, then we say thousands. What's the number before the comma? 56. So this number is 56,000. New number. What's the number before the comma? 17. Say the whole number. Yes, 17,000. New number. What's the number before the comma? 342. Say the whole number. $342,000. When we rewrite numbers for borrowing, we end up with a 2-digit value in one of the columns. In this problem, the 8 is underlined. That means that we want the 8 changed into a 2-digit value. Say the digit we'll cross out. We cross out the 6 and write a number 1 less. In which column do we write the one we borrowed? Here in the tens column. Say the new 2-digit value in the tens column. There's 18 in the tens column. We've worked problems like this before. The tens column begins with the smaller number, so we borrow and rewrite the first 2 digits of the top number. The problem in the ones column says 6 minus 5 equals 1. In the tens column, the problem says 6 minus 9. Can we work that problem? We can't work the problem, so we borrow. Which digit do we cross out in the top number? We cross out the 4 and rewrite 46. Say the new problem in the tens column. It's 16 minus 9. That's 7. Say the new problem in the hundreds column. It's 3 minus 1, and that's 2. Here's a number that has been rewritten for borrowing. The tens digit is crossed out, and there's a 2-digit value in the ones column. For some problems, we have to borrow again. We do that by rewriting the first 2 digits so that the 3 becomes a 2-digit value. We cross out the 7. What do we write above the 7? Yes, a 6. And we write the one that we borrowed in front of the 3. Now the 3 is a 2-digit value, 13. We have 6 hundreds, 13 tens, and 12 ones. In this problem, we have to borrow for the ones column and for the tens column. Say the problem in the ones column. Can we work 5 minus 7? We can't work it, so we rewrite 45 to get a 2-digit value in the ones column. Say the new problem in the ones column. What's the answer for 15 minus 7? It's 8. Say the new problem in the tens column. Can we work 3 minus 8? We can't work it, so we rewrite 73 to get a 2-digit value in the tens column. Say the new problem in the tens column. What's the answer for 13 minus 8? It's 5. Say the new problem in the hundreds column. What's the answer? It's 4. That's all there is. We're going to work subtraction problems. Sometimes we'll borrow once. Other times we'll borrow twice. Say the problem in the ones column. Can we work 3 minus 4? We have to borrow. Say the new problem in the tens column. Can we work 6 minus 9? We have to borrow. What do we write for the answer in the hundreds column? The answer is 0, so we don't write anything. New problem. Say the problem in the ones column. Can we work 4 minus 2? The answer is 2. Say the problem in the tens column. Can we work 0 minus 6? We have to borrow. What do we write for the answer in the hundreds column? 3. One more. Say the problem in the ones column. Can we work 2 minus 5? We have to borrow. Say the problem in the tens column. Can we work 3 minus 1? What's the answer? 2. What do we write for the answer in the hundreds column? 1. See? Problems like these aren't hard as long as you take them a step at a time. Here's a subtraction problem with thousands numbers. We work this problem just like any other subtraction problem. We start in the ones column. We don't have to borrow. What's the answer? Yes, 0. Next we work the tens column. Do we have to borrow? No borrowing. What's the answer? 1. Next we work the hundreds column. Do we have to borrow? We can't work 8 minus 9, so we borrow. The new problem in the hundreds column is 18 minus 9. What's the answer? 9. Say the new problem in the thousands column. 6 minus 1. What's the answer? 5. Remember, you'll work problems with thousands numbers just like other problems. Start with the ones column and work the problem a step at a time. Here are some numbers that end in 0. We're going to rewrite each of these as some number plus 1. The first number is 70. 70 equals some number plus 1. 69 is the missing number. 70 equals 69 plus 1. The next number is 50. 50 equals some number plus 1. What's the missing number? Yes, 49. 50 equals 49 plus 1. The next number is 20. 20 equals some number plus 1. What's the missing number? Yes, 19. 20 equals 19 plus 1. The next number is 100. 100 equals some number plus 1. What's the missing number? Yes, 99. 100 equals 99 plus 1. The next number is 400. This one is hard. 400 equals some number plus 1. The number that is 1 less than 400 is 399. 400 equals 399 plus 1. The next number is 700. 700 equals some number plus 1. Think about it. What's the missing number? Yes, 699. Here's a new kind of borrowing problem. We have to borrow to work the ones column. Here's a rule. We can't borrow from a 0. We have to borrow from the first digit that is not a 0. The tens digit of 301 is 0. We can't borrow from it. We have to go to the first digit that is not a 0. That's 3. We're borrowing from 30. We cross out 30 and rewrite it as 29 plus 1. We rewrote 30 as 29 plus 1. Now we can subtract. New problem. We have to borrow to work the ones column. We can't borrow from this 0 or from this 0. We go to the first digit that is not a 0. We're borrowing from 300, so we cross out 300 and rewrite it as 299 plus 1. We rewrote 300 as 299 plus 1. Now we can subtract. New problem. We have to borrow to work the ones column. We can't borrow from this 0 or from this 0. We go to the first digit that is not a 0. We're borrowing from 200, so we cross out 200 and rewrite it as 199 plus 1. Now we can subtract. Here's a subtraction problem. We start in the ones column. Do we have to borrow to work the ones column? We can't work 4 minus 5, so we borrow. What value do we cross out and borrow from? We can't borrow from 0, so we borrow from 60. We rewrite 60. We subtract, and we get 469. New problem. We start in the ones column. Do we have to borrow to work the ones column? We can work 5 minus 4. The answer is 1. Do we have to borrow to work the tens column? We can't work 0 minus 3, so we have to borrow. What value do we cross out and borrow from? We borrow from the 7. We rewrite it, and then we subtract. When you work subtraction problems, you have to be careful. Sometimes you don't have to borrow from 0. In other problems, you do have to borrow from 0. You won't get confused if you always read the problem in the column you're working and then decide if you have to borrow. We're going to work some problems that can be a little tricky, but we'll work them a step at a time and not get fooled. We start in the ones column. Say the problem in the ones column. 0 minus 9. Do we have to borrow? We can't work 0 minus 9, so we have to borrow. What value do we cross out and borrow from? We borrow from 600. We can't borrow from this 0 or from this 0, and 6 is the first digit that is not a 0. We rewrite 600, and now we can subtract. New problem. We start in the ones column. Say the problem in the ones column. 0 minus 0. Do we have to borrow? We don't borrow. 0 minus 0 is 0. Next to the tens column. Say the problem. Do we have to borrow? We can't work 0 minus 9, so we borrow. What value do we cross out and borrow from? We borrow from 60. We can't borrow from this 0, and 6 is the first digit that is not a 0. We rewrite 60, and now we can subtract. One more. We start in the ones column. Say the problem in the ones column. 0 minus 1. Do we have to borrow? We can't work 0 minus 1, so we have to borrow. What value do we cross out and borrow from? We borrow from 60. We can't borrow from this 0, and 6 is the first digit that is not a 0. We rewrite 60, and now we can subtract.
Here's a number family that goes to the side. In this family, the big number is missing. Here's the same number family going down. The small numbers are still the same. What are the small numbers? 9 and 8. The big number is at the bottom, and the arrow still points to it. Here's a family with the small number missing, and here's the same number family going down. We figure out the missing number by starting with the big number and subtracting. What's the big number? 14 is the big number. Say the subtraction problem that starts with 14. Here's the problem. What's the answer? 8. The columns in this table work just like number families that have the arrow going down. The big number is at the bottom. That's the total. The small numbers are above the big number. In this column, is the big number or a small number missing? A small number is missing. Say the problem for finding the small number. 22 minus 17. In this column, is the big number or a small number missing? The big number is missing. Say the problem for finding the big number. 15 plus 9. In this column, is the big number or a small number missing? A small number is missing. Say the problem for finding the small number. 37 minus 14. We've worked table problems by finding the missing number in rows and in columns. Each row and each column works just like a number family. In these rows, the small numbers are in red. The black numbers are for the totals, the big numbers. And in these columns, the small numbers are in red. The black numbers are for the totals, the big numbers. Here's a rule about rows and columns. First, for rows. If there are two numbers in a row, you can figure out the missing number. If there is only one number in a row, you can't figure out the missing number. And for columns, if there are two numbers in a column, you can figure out the missing number. If there is only one number in a column, you can't figure out the missing number. Here's a table that shows the red bikes and green bikes that were painted on Monday and Tuesday. Some of the numbers are missing. This row shows the number of red bikes painted on Monday and Tuesday. This row shows the green bikes painted on Monday and Tuesday. The total row shows the total bikes painted on Monday, on Tuesday, and the total of all bikes painted on both days. This column shows the red bikes and green bikes painted on Monday. The second column shows the red bikes and green bikes painted on Tuesday. The total column shows the total red bikes painted on both days, the total green bikes painted on both days, and the total of all bikes painted on both days. The total of the totals is the same for the rows and the columns because it shows the total number of red bikes and green bikes painted on both days. Here's a table with some missing numbers. The table shows the number of big trucks and small trucks on Main Street and Elm Street. Here's a fact that tells about one of the missing numbers in the table. On Main Street, there are 21 fewer big trucks than small trucks. The fact tells about the big trucks on Main Street and the small trucks on Main Street. The fact says that there are fewer big trucks, so B is a small number. S is the big number, and 21 is the other small number. The table gives a number for one of the letters, so we put in the number we know from the table. The answer to the number problem is 32. 32 tells the number of small trucks on Main Street. Now there are enough numbers in the table to work the problem. We've worked different kinds of word problems. For some problems, the first sentence tells how to make the number family. Here's a problem like that. Juanita rode her bike 11 miles farther than Adam. Adam rode 9 miles. How many miles did Juanita ride? The first sentence says that Juanita rode farther. The first sentence tells which person is the big number. Who is the big number? Juanita is the big number. She rode farther. Here's a different problem. Juanita rode a bike for 52 miles. Katie rode for 36 miles. How much farther did Juanita ride than Katie? The first sentence says that Juanita rode 52 miles. That doesn't tell which person is the big number. The second sentence says that Katie rode 36 miles. That doesn't tell which person is the big number. The last sentence says, how much farther did Juanita ride than Katie? The last sentence tells which person is the big number. Who is the big number? Juanita is the big number again. When working problems like these, be careful. Sometimes the first sentence tells how to make the number family. In other problems, the last sentence tells how to make the number family.
Here is another problem that has 3 parts. If a girl is 24 years younger than her mother, and if her mother is 31 years old, how old is the girl? The first part tells how to make the number family. A girl is 24 years younger than her mother. The next part tells a number that goes in the family. Her mother is 31 years old. And the last part asks the question, how old is the girl? When you work these kinds of problems, you have to read the problem carefully to find the 3 parts.
This problem looks like the ones we've worked before, but it doesn't have a box. It has the word sum instead. Sum doesn't tell us what number to write, so we write a box. Listen to the problem. You have sum. You find 45. You end up with 75. Are you getting more or getting less in this problem? You're getting more. So do the values go forward or backward? The values go forward along the arrow. Here's another problem. You have 87. You lose some. You end up with 62. Are you getting more or getting less in this problem? You're getting less. So do the values go forward or backward? The values go backward along the arrow. Remember, for problems like these, make a box for the word sum. You've worked problems like this. If you get more, the values go which direction along the arrow? They go forward. And if the problem tells about getting less, the values go which direction along the arrow? They go backwards. Here's a problem that works the same way. Abe had 36 dimes. He spent some dimes. He ended up with 19 dimes. How many dimes did he spend? Is Abe getting more or getting less in this problem? He's getting less. So do the values go forward or backwards? The values go backwards. Here's another problem. Abe had 36 dimes. He earned some more dimes. He ended up with 89 dimes. How many dimes did he earn? Is Abe getting more or getting less in this problem? He's getting more. So do the values go forward or backward along the arrow? They go forward. Remember, problems like these work the same way as other problems you have worked. If you get more, the values go forward along the arrow. If you get less, the values go backwards. Here's a problem that's just a little harder than the ones you've worked before. The resort is 47 miles farther away than the city. The resort is 199 miles away. How far away is the city? The thing that is farther away is more miles away. It is the big number. Listen to the first sentence again for the big number. The resort is 47 miles farther away than the city. Which is the big number, the resort or the city? The resort is the big number. The small numbers are city and 47. New problem. The magazine took 5 hours to read. The book took 13 hours longer to read than the magazine. How many hours did it take to read the book? The second sentence tells about the big number. Remember, the thing that takes longer is the big number.